Hi, my name is Rodrigo Badia. I am a member of the research group ModelFLOWs, and in this video, I'm going to present you the module in which I have been working on, that is called Full Deep Learning. So let's start with the motivation that led not only to the development of this module, but also to a paper that is already available on arXiv. In this paper, we decided to measure the performance of deep learning modules when they are applied to a temporal forecasting problem in different fluid dynamics datasets. The difference between these models and the models inside the hybrid deep learning module is that here we do not perform any preprocessing step using SVD or POD in order to reduce the dimensionality of the original datasets. So let's continue with the methodology that we use in this paper, where we presented two deep learning models, one that is called CNN and another one that is called RNN. Both of these models can accept as input a number of samples that the user can customize, and it will return a number of time ahead predictions that the user can also customize. In our study, we set these numbers as 10 and 2 respectively. As you can see on the left column, the RNN model is mainly composed by an LSTM layer, while the CNN model is mainly composed by convolutional neural networks. So let's continue with the data preparations, where our models accept as input two different data sets, one that is going to be used for training and validating the models, and another one that is going to be used for testing. So both of these data sets are four-dimensional tensors, where the first dimension is related to the number of variables that can be considered as the velocity components, like string-wise, span-wise, or normal velocity. The second and third dimension is related to the spatial dimension, where the second dimension is related to the x-axis and the third dimension is related to the y-axis. And finally, the last dimension is the temporal one, because it is related to the number of samples. So let's continue with the calibration of both models. And please note that here I am just going to explain 5 hyperparameters available on the models, inside the models. But on the paper of the app, there is a table with all the hyperparameters available for customization and a brief explanation of each one. So let's starting with the first one, that is the training size. As I said before, these models accept as input one dataset that is going to be used for training and validating the models. Inside this dataset, the user have to specify which percentage to use for training, and the remaining are going to be used for validation. So let's continue with the next one, that is which model to use in order to perform the forecasting. In our study, we found out that the CNN model is the one that returns the optimal predictions. So the next hyperparameter is the batch size. And in our study, we set this hyperparameter to be 5, but other popular options are 8, 16, 32, or even 64. And finally, is the number of epochs to use for training or the training length. In our study, we set this number as 140, but other popular options are 100, 200, or even 1000. So let's see one of the results that this module returned. That is a snapshot comparing on the left column the target or the snapshot that we want to predict. On the middle column, the prediction returned by one of the models, and on the right column, the absolute difference between the ground truth and the prediction. So this is it. And if you want more information, not only about the module, but also about the study that we have carried out, please check this link below. So thank you so much for watching, and please visit us on ModelFLOWs.es.